Power is a physical concept that has several different meanings, depending on the context and the information that is available. Power can be a measurement of how much work someone or something performs over time. In a second context, power can be calculated as a function of velocity, how quickly you get a weight to move. Finally, electrical power is the product of voltage and current. If you know the context and you know which measurements you have to start with, you can select the appropriate formula and calculate power output. So, we are going to watch about the how to calculate power output. Method 1. Calculating mechanical power as a function of work.
First is calculate work.
In mechanical physics, work is the amount of force needed to move something over a selected distance. The formula for work is work equals force asterisk operator distance display style text work equals text force asterisk text distance. To understand this concept, think about a 100-pound cement block. Moving that block 2 feet requires twice as much work as moving the same block 1 foot. This is also the same amount of work required to move a 200-pound block for a distance of 6 inches. 1/2 a foot.
Step 2. Define mechanical power.
Power is the rate at which work is performed over time. The basic formula for defining power is power equals work time display style text power equals frac text work text time. Think again about the 100-pound cement block. Moving that block 2 feet in 10 seconds requires twice as much power as moving the same block for the same distance in 20 seconds. Moving the same object faster requires more power. Step 3. Determine the units you're using for work and power. You need to determine whether you are measuring work and power in traditional English units or in metric units. The English unit for work is the foot-pound. This comes from multiplying the distance measured in feet by the force measured in pounds. The unit for power comes from dividing by time, in seconds. The power unit is the foot-pound per second. A more familiar term is the horsepower, which is defined as 550 foot-pounds per second. 1 horsepower equals 550 foot-pounds sec. Display style 1, text, horsepower, equals 550, frac, text, foot-pounds, text, sec. Closing curly bracket closing curly bracket closing curly bracket closing curly bracket. The metric unit for work is a joule. A joule is equal to 1 Newton meter, which is the amount of work needed to move a 1 Newton force a distance of 1 meter. When you divide work by time, you get power, measured in units of joules per second. This is also called a watt. 1 watt equals 1 joule sec equals 1 Newton meter sec. Display style 1, text, watt, equals 1, frac, text, joule, text, sec equals 1, frac, text, Newton meter, text, sec.
Step 4. Collect the available data.
Whether you are solving a physics problem in class or are actually calculating power from a real-world application, you need to collect certain information first. You can learn the information that you need by reviewing the measurement units. For example, suppose you want to calculate in the following problem. A student doing chin-ups lifts his 150 pounds body a distance of 1.5 feet in 2 seconds. How much power is the student exerting? Force equals 150 pounds. Display style, text, force, equals 150, text, lbs. Distance equals 1.5 feet, display style, text, distance, equals 1.5, text, feet. Time equals 2 seconds. Display style, text, time, equals 2, text, sec.
Finally, multiply force by distance and divide by time.
Whether in the metric system or the English system. Once you have collected the data for the force, the distance and the time, apply them to the formula to find the mechanical power. Power equals force asterisk operator distance time display style text power equals frac text force asterisk text distance text time. Power equals 150 lb 5 feet 2 seconds. Display style text power equals frac 150 text lb 5 text feet 2 text sec. Power equals 225 feet lb 2 seconds. Display style text power equals frac 225 text ft lb 2 text, sec. Power equals 1125 feet lb sec. Display style, text, power, equals 1125, frac, text, FTLB, text, sec. Since 1 horsepower equals 550 feet lb, sec. This is about equal to 1/5 of a horsepower. Method 2. Calculating mechanical power as a function of velocity.
First is rewrite the formula for power.
The original formula for power focuses on work as a force times distance, and divides by the time it takes to do that work. Another way to consider the same components is as follows. Power equals force, asterisk operator, distance, time, display style, text, power, equals, text, force, asterisk, frac, text, distance, text, time. By grouping the terms differently, in this way, you should recognize that distance, time, display style, frac, text, distance, text, time is another way of representing velocity. Therefore, you can conclude that power equals force, asterisk operator, velocity, display style, text, power, equals, text, force, asterisk, text, velocity. Consider a 2,000 pound car. Moving that car at a speed of 50 miles per hour takes twice as much power as moving the same car at a speed of 25 miles per hour.
Step 2. Convert the units as needed.
The units of power are generally calculated in either watts, which are joules, sec, or Newton meters per second, or in horsepower, HP, or foot-pounds per second. Recall that 1 horsepower equals 550 feet lb, sec. If your situation or problem presents data in different units, you will have to convert. Some of the most useful conversion factors are: 1 mile equals 5,280 feet. 1 hour equals 60 minutes equals 3,600 seconds. 1 kilogram equals 9.8 N. Force. For the moving car problem, the data is provided in miles, hours and pounds. You need to convert 50 miles into 50 times 5,280 equals 264,000 feet, and convert hours into 3,600 seconds. Then you can restate the problem as calculating the power of moving a 2,000 pound car at a velocity of 264,000 divided by 3,600 equals 33 feet per second.
Finally, multiply the force by the velocity.
When your data is in the correct format, you can calculate power as the product of force times velocity. For the car problem, this becomes power equals force, asterisk operator, velocity, display style, text, power, equals, text, force, asterisk, text, velocity. Power, equals, 2000, pounds, asterisk operator, 33 feet sec, display style, text, power, equals 2000, text, pounds, 33, frac, text, feet, text, sec. Power, equals, 146,660, foot-pounds, sec, display style, text, power, equals 146,660, frac, text, foot-pounds, text, sec. You can report this as the car's power, or convert to horsepower by dividing by 550. Power equals 146,660 divided by 550 equals 266. 65 horsepower, display style, text, power, equals 146,660 divided by 550 equals 266. 65, text, horsepower. The engine exerted 265 horsepower in moving the 2,000 pound car at a velocity of 50 miles per hour.
Method 3. Calculating electrical power. First is record the circuit's voltage.
A circuit's voltage is analogous to the force applied in a mechanical movement. The voltage tells you how much electrical charge is being passed through a circuit. Just as moving a heavy block of cement requires great mechanical power, moving a high voltage requires a large electrical power output. Voltage is measured in units called volts, abbreviated V. In equations, the voltage is represented by the symbol A. If you are reading a circuit diagram, the voltage will be written somewhere on the diagram. If you are building an actual circuit, the voltage is the power coming from the battery source. For example, a single 9-volt battery provides 9 volts to the circuit.
Step 2. Record the circuit's current.
The current of an electrical circuit is analogous to the velocity applied in a mechanical movement. The current tells you how fast the charge is being passed through the circuit. Current is measured in units called amperes, abbreviated as amps or just A. In calculations, current is symbolized by the capital letter I. Current can be measured directly using a reader called an ammeter. Alternatively, the problem you are working on may simply provide the number of amps in the circuit. For example, a circuit that has a current of 4 amps is moving the charge twice as quickly as a circuit with a current only 2 amps.
Step 3. Define electrical power.
Just as power can be defined in the mechanical sense as the amount of work exerted over time, electrical power is also an amount of work exerted over time. However, with electrical power, the work that is calculated is the work of moving electrons through an electrical circuit. A circuit that moves more electrons or moves them more quickly will be defined as having greater power. The unit of electrical power is the watt. It is calculated as follows. Power equals current asterisk operator voltage display style text power equals text current asterisk text voltage. P equals I A display style P equals IE.
Finally, calculate the power of a circuit.
Suppose a given electrical circuit has a current of 6 amps and a charge of 18 volts. To calculate the power in the circuit, you need to multiply as follows. Power equals current asterisk operator voltage display style text power equals text current asterisk text voltage. Power equals 6 asterisk operator 18 equals 108 W A T T S display style text power equals 6 times 18 equals 108 watts.
We hope it is useful to you. Please subscribe to our channel to upskill yourself.